Hi, in this video, I will be showing you problem number 1 of chapter 4 section 5 from the practice exam. Use the guidelines of this section to sketch the curve y equal to x cube plus 3x square. We'll find out the domain. So y equal to x cube plus 3x square is a polynomial. Being a polynomial, the domain is going to be all real numbers. So domain is all real numbers. You can write this as or you can write in the interval form negative infinity through positive infinity. And then we are going to find out the x-intercept and the y-intercept. So x-intercept is obtained by setting y equal to 0. So x cube plus 3x square equal to 0, which would mean x squared can be factored out. So x plus 3 equal to 0. Either x equal to 0 or x equal to negative 3. So 0, 0 and negative 3, 0 are the x-intercepts. Y-intercept is obtained by setting x equal to 0. So when x equal to 0, it will mean y equal to 0. So the y-intercept is the origin, x-intercept is 0, 0, and negative 3, 0. These are the x-intercept. Y-intercept is x0, y0. So as the expression, the function has a cube and a square. This doesn't have any symmetry involved. There is no symmetry about x-axis or y-axis. And then being a polynomial, there is no asymptote. F of x does not have any asymptote. The graph does not have asymptotes. To see whether the graph is increasing or decreasing, we are going to do the ID test, which is increasing decreasing test. For that we are going to find out the derivative. The derivative is 3x square plus 6x. So if I take the 3x out, it will be x plus 2. So equal to 0. This will give us the critical points. So either x equal to 0 or x equal to negative 2. So on the number line, if you place negative 2 and 0 and take test points in these three intervals, we can find out where the graph is increasing or where the graph is decreasing. If f prime x is positive, then the graph is increasing. If f prime x is negative, then the graph would be decreasing. So by placing negative 2 and 0, the critical points on the number line, and then we divide the number line into three parts: negative infinity to negative 2, negative 2 to 0, and 0 through infinity. In each of these intervals, you take a test point and then plug it into f prime, and we actually see f prime negative 3, which is in this interval negative infinity to negative 2, f prime is more than 0. And then in this interval negative 2 to 0, I took the test point negative 1. If we plug it into f prime, we get a less than 0. Then on the interval 0 through infinity, the test point is considered as 1. F prime 1 is more than 0. So whatever is the behavior of the test point is the behavior of the interval. Every point in that interval. So we notice f is increasing on the interval negative infinity to negative 2, decreasing on the interval negative 2 to 0, and again increasing on the interval 0 through infinity. We write f is increasing on negative infinity to negative 2 and 0 through infinity union. Then f is decreasing on the interval negative 2 to 0. graph is increasing up to -2 and then it decreases after -2. So that is, it's increasing and then decreasing at the point -2. So there is a peak at that point -2. So the local maximum value is f at -2. So we have to plug in into the original function, which is x cubed plus 3x square. So -2 cube plus 3 times -2 square. So if you find this value, this will be 4. So the local maximum value is 4. So then we have to find out local minimum value, if there is any. Whenever the graph decreases up to 0, so -2 to 0 decreases, then 0 through infinity it increases. So at -2 there is a x coordinate is -2, then we have to find out what the y coordinate is at 0. At 0, that's where the local minimum occurs. So it decreases up to 0 and then 0 to infinity it increases. So f at 0 equal to 0. So the local minimum value for this function is 0. Next we have to determine whether the graph is concave upward or concave downward. For that we have to find out the second derivative, which is a derivative of the first derivative. The first derivative in this step is 3x squared plus 6x. We are going to differentiate that to get the second derivative, which is 6x plus 6. Then in order to find out the critical number, so it's 6 times x plus 1. We'll set this to 0. So we get x equal to -1. So we divide the number line from -infinity through -1, and then -1 through infinity. The previous part we will take a test point here, which is 0. Here we will take a test point which is -2. Then we will plug in into the second derivative. So when we do f double prime 0, it's going to be 6, which is positive. This tells that the graph is concave upward on the interval -infinity through -1 through infinity, that is concave up. Then we take the -2 as the test point on the interval -infinity through -1. F double prime -2 would be 6 times -2 plus 6, which will be negative, which is concave downward. So in this interval, in this -infinity through -1, it is concave downward. So we'll write that part. So f is concave up on -1 through infinity. F is concave down on -infinity through -1. So obviously wherever the concavity changes, the inflection point occurs. So this last part, where is the inflection point? So the concavity changes at -1. So x coordinate of the inflection point would be -1. But the y coordinate we have to determine, because it's a point, we have to determine x comma y. So if you plug it in into the original function, x cube plus 3x square. So -1 cube plus 3 times -1 square, which is -1 plus 3, which is equal to 2. So the inflection point is going to be -1, 2. Final thing is to graph this function f of x. We notice that there are X-intercept and Y-intercept are -3 and 0 are the X-intercepts, Y-intercept is 0. So we have to mark those X-intercept and the Y-intercept on the graph, and we found that -2, 4 is the local maximum, which is -2, 4, and then local minimum is 0, 0, which is local minimum is attained at 0, the value is 0. So it's 0, 0 is one important point. Negative 2, 4 local max. And we also found wherever the concavity changes, which is the inflection point, which was negative 1, 2. So negative 1, 2, which is an inflection point. So when you graph when you sketch these kind of graphs, they make sure that you show the important points that you found out in different parts of the problem on the graph. Hope this video helps.